Hi, this is Charles from Atlantic CAD Solutions. Service New Brunswick recently released some LiDAR data for the province of New Brunswick. So what I'll do today is I want to show you how to download the data and unzip it. Then we'll jump into Civil 3D and I'll show you how to build a surface from all of that. All right, so let's get started. So first of all, I'll go to the GeoNB website, and I'm gonna download a tile of LiDAR. So simply head over to their standard website, geonb.snb.ca, and what I'll do is I'll go directly to their catalog, data catalog. And you'll notice there's a new entry here for LiDAR data. So that's where I'll go, select data. And then as you zoom in, you'll notice that there's little tiles, and each red tile is a tile of data that you can download. So, all right, well, let's pick on Fredericton today. So you just click on the red tile. This gives you access to the link to download the data. All right, and then as you can see at the bottom here, it's going to be downloading a LAZ file. LAZ is an LAS file, except that it's zipped. All right, so a typical LAS file could be over 300 megabytes, but since it's zipped, it's only 32 megs, so it's easy to download. All right, so if I look at the what I just downloaded, it's just a simple LAZ file that's 33 meg, right? So next, what we need to do in order to use the data is we need a LAS file. In other words, we need to unzip the LAZ as a straight LAS, and then we can start using that in Civil 3D. So in order to do that, we have to download a LAZ unzipper. All right. So one free app that's available is on the laszip.org website. So I'm going to head over there, laszip.org. And on that website, you can download a little app. It's really tiny app here, laszip.exe. So I'll just click on that to get that, save it. And then if I look in my downloads, you'll notice it's just a sort of a one file type app here, an exe app. So I'll double click on that and run it. In the LASZip application, I'm going to start by browsing to my file. All right. In this case, my file was downloaded in my downloads folder. So I'll go there and double click on your file here to load it up. Now to make this whole process much easier for us, what I'm going to do is I'm only going to extract or unzip the ground shots. Now, if you're not familiar with LAS LiDAR files, in the LAS file, each point will have a X, Y, Z information. It also has a classification value. So every point has a class. And then each class is described down here in this little table. All right. So some points will be classified as with a value of 2. Some of them will be vegetation, so they'll be in a class of 3, 4, or 5. As you can imagine, downtown Fredericton, there's going to be a bunch of buildings, so there's going to be a ton of points classified 6. Okay. So for us, for our Civil 3D terrain model we're trying to generate here, we're really interested in the ground shots. Okay, so I'm only going to extract the ground shots, and I'm going to ignore the rest of the points. All right, the rest of the points are bad for ground surfaces. So I can do this here by going to this filter section, and I'm gonna filter this by classification. Keep classification, and then the value of 2. So I'm only gonna keep the ground shots. In other words, I'm gonna add this, and that's gonna be a filter. Next, head over to the right side. I'm going to use the LAS format, and then you just got to simply press decompress. It's going to create a little script, and we're going to click start to run it. Takes a few seconds, but now in my downloads folder, you'll notice I have a LAS file. All right, and it should only contain the ground shots. All right, now that we have the LAS file that's compatible with Civil 3D, before I go to Civil 3D, I'm going to use Recap, the Recap application. All right, so Recap is a free app that usually ships with your Civil 3D. So whenever you install your Civil 3D on your computer, it should also install Recap. All right, so Recap is used to load up the data. It's going to be used to visualize the data. You can also aggregate data. So let's say you have multiple tiles of LiDAR that you want to build a surface from. Well, you can sort of merge in or aggregate all the tiles in Recap, and then sort of output the results back to Civil 3D. All right. Same goes for cropping. So let's say you just need a street out of the big tile, so you can sort of crop down your project and only move those points forward. So in Recap here, I'll go to I'll start a new scan project, and I'll give it a name. I'll call this LiDAR from GeoNB. Proceed, and what I'll do is I'll select the file, my LAS file that we just unzipped. All right, so you can add one or more files, all right, and sort of aggregate a bunch of LiDAR data at this point. All right, so now that everything's been loaded, I'll go to launch project, and I'm going to check out my results here. So this is the tile that we downloaded. Now things are pretty ugly at this point because all the points are black. If you want to add a little bit more color to this, you can go to a little computer screen icon, and there's a bunch of color options. You can go by elevations, for example. So you'll notice here at this point we get the LiDAR. But only the ground shots. You'll notice all the buildings downtown, they've all been sort of cropped out there. All right, if I try to flip this, you'll notice that there's no trees, there's no light poles or hydro poles. All right, perfect. Now at this point, in order to move on to Civil 3D, what I'll do is I'm going to save this. And I'm going to save this as a recap project or a RCP file. All right, and that RCP is going to be compatible with Civil 3D, and then you can start building your surface from that. So I'll save that up here. So you bring your LAS in Recap, one or more LAS, doesn't matter, and you build your or you save your Recap project, your RCP file. All right, let's go over to Civil 3D and build the surface. All right, once in my Civil 3D, the first thing we'll do is we'll attach the point cloud previously generated in Recap. So to do so, I'll go to the Insert tab and click Attach Point Cloud. Select your recap project. And here you just want to make sure that you're not changing the insertion point, the scale, or the rotation. So we're not shifting the coordinates of those points. So I'll just go ahead, click OK, and get my point cloud attached. In Civil 3D, the point cloud is really similar as in Recap. So I can select the point cloud object on the screen. The contextual ribbon comes up, and you can sort of play with the coloring if you want. To get things to pop up a little bit more. You're also going to notice there's some cropping tools, so you can sort of further crop your model or your point cloud. All right, now that I have my point cloud, we're going to build a surface from it. So to do so, we'll head over to Home, Ribbon tab, Surfaces, and Create Surface from Point Cloud. I'll select my point cloud object and go through this wizard. Give a name to your surface and the style. Perfect. In this case here, I'll use 100% of the LiDAR information. All right, so 100% of the LiDAR results in a surface that's going to contain 1.7 million points. Wow, that's a lot of points. So let's use everything here. I'll go next. Here it gives us some options for filtering. So if your LiDAR hasn't been filtered yet, you can sort of do so at this point. Now, since we've already filtered out the points, since we've already unzipped the LAZ and only unzipped the point classification of number 2, which are the ground shots, it's already been filtered. So I'm going to use the no filter here to go forward. And I'll say create surface. Perfect. The surface creation will happen in the background. So it just means that you're able to sort of work as your surface gets built as a background process. Whenever it's going to be done, you're going to have a little box here that's going to come up indicating that the surface is done. Perfect, and that's it. We just built a surface containing 1.7 million points in about a minute. So that's pretty good. All right, next, well, let's look at the surface. What I'll do is I'll select the point cloud here, and up in my contextual ribbon under Point Cloud Manager, I'm just going to use that to turn off the display of the point cloud. Perfect. All right, so look at this. Wow. So if I grab the surface and have a look at it in 3D, I'll spin that around and try to zoom in to see the results. So I'll zoom in, sort of close in onto Queen Street and the entrance of Westmoreland Bridge. So as you can see here, the definition of the LiDAR is really good, all right? But typical to LiDAR, you get more information than what you actually need. All right, so you look here at the intersection of Queen Street and Westmoreland. Notice how many triangles are in this small area. I mean, this is overkill for an existing ground surface. All right. The other problem that we get with LiDAR surfaces is the size and how much is going to weigh, on your in your software. So if I look at the size of this surface again through my surface properties, I mean, we have 1.7 million points, and if I look at the tins, we get, how much is that? 3.5 million triangles. This is way too big, all right? I wouldn't recommend carrying forward with any type of design with this surface side. It's just going to bog down your drawing. If I save this file just for fun, and I'm going to look at the drawing properties to see the size, the file size of this surface in a civil drawing. I'll just go ahead over to drawing and utilities, drawing properties. And look at this, all right? The only thing in my file right now is a surface. One tile is 125 megabytes. All right, so obviously it's not recommended to carry forward in any sort of design project or design jobs from that surface. There's too much data. Okay, so what we need to do next is we need to simplify this. We need to bring this back under control. And one good way to do this is to head over to the prospector and modify the surface. All right, so I'll go to my surface definition here. I'll right click on edits, and a command that came out back in 2009 is called simplify surface. Really neat command. So it offers two ways to simplify the surface without affecting the accuracy of the surface. So this is, you get the best of both worlds. You get to reduce the size of the surface, but you get to keep your accuracy there. So it offers two methods. There's edge contraction and point removal. I would encourage you to read up on it through the help file to see what method does what. But I'll use the edge contraction here, and I'll use the entire surface. And what it's going to do is going to try to merge triangles together into a more simplified triangulation. So it's going to remove triangles here. So what I'm going to do here is I'm going to boost this way up. I mean, you can experiment with this, trial and error, and try to get the surface size that you want, but I'm going to boost this way up to 95%. We'll try that. All right. Yeah, and that's it, 95%. We'll give it a shot and check out the results. So I'll click on finish. Now take note, this is going to take several minutes to process. So I'll click on finish and pause the video, and we'll get back to it once it's over. All right, now that my surface has done processing and simplifying, let's check out the results. First, let's check out how many points do we have. So number of points in my surface here, I'm down to 88,000 points. So I'm down from, I started at 1.7 million down to 88,000. So this is great news. And as far as my tin over here, I'm down to 176,000 triangles in my surface, down from over 3 million, if I remember correctly. All right, so this is great. This is going to make it so that the surface is really fast. It's still high-end, still a high-end surface, but it's not going to bog down your machine, and it's not going to bog down, slow down the rest of your design project moving forward. If I look at my drawing properties here to see the file size, see, I started at 125 meg down to 36 megabytes. So this is great. This is a perfect civil 3D surface here. Let's have a final look at the object viewer. So I think before we're looking at the intersection of Queen Street and Westmoreland. And you can sort of see that the rows are still nicely defined. Still lots of triangle, a lot more than actually what we need there, but it's good enough. Job complete for now. My name is Charles, and I'm with Atlantic CAD Solutions. Thank you very much.